Okay. Let's see.
Hello everyone. Our third speaker is Athir Altar, the lead data scientist of TIBCO Group. TIBCO is one of our gold sponsor. Athir will be speaking on real-time completion survey and analysis. Athir, all over to you.
Hi, good morning, everyone. Thanks, Alex, for the introduction. Thank you all for having us today. My name is Athir Al-Attar. I'm a lead data scientist at TIBCO Analytics team. I'm focusing on oil and gas. And today I'm going to talk about digital twins in general, along with a couple of success stories from Mercedes-Benz team, Formula One, and a well completion use case that we worked on at TIBCO. We will also have a Q&A at the end of the presentation. So here's the agenda for today. I will go through like a historical perspective on the digital twin and the context of the digital twins. I will give a couple of industry examples and different verticals. We'll also touch on the TIBCO technological stack that we use to create the demo and completion. And we'll also touch on some some successful stories for using digital twins and using the TIBCO technological stack. So the concept of the digital twin itself was anticipated by Yale computer science professor David Gelenter in his book Mirror Worlds in 1991, as he imagined the world where you can see a whole city traffic represented live on your computer screen, or how it will be possible for you to like tour a whole hospital or a school from your desktop with a continuous flow of real-time data. And that's the maybe like one of the main concepts of the digital twins, is using the real-time data for this system. So the digital twin is a virtual representation of a physical object or a process. But the word itself, the digital twin, was that one of the early adoptions of this word was by John Vickers from NASA in 2010, in their simulation roadmap. And then they described it as an integrated multi-physics and multi-scale probabilistic simulation of a vehicle system that uses the best available physical models, sensors updates, fleet history, etc., to mirror the life of its flying twin. So the digital twins cannot be only a representation of an object. It can be a representation of a process that replicates the digital copy, or it can be like a whole system or like a part of that system. Now, some of the questions that we see nowadays is the digital twin a simulation? Or like, what is the difference between a digital twin and a simulation? So the simulation is an imitation of a real process or entity that includes models and parameters. Although simulations are an important part of many industry verticals, setting the simulation scene is not a straightforward process. Sometimes, or most of the time, is an expensive process. And then also the simulation must contain a model and then some set of parameters and a way to validate your outputs. Moreover, the simulation setups are expensive, like, for example, the self-driving cars manufacturers when they set up a simulation. While digital twins enable companies to simulate real products or systems to identify any optimization opportunities or any potential problems. They also directly impact the enterprise decision-making when it comes to systems analysis and optimization. And then while simulations help us to understand what might happen, the difference here with the digital twins, they also help us with knowing what might happen, but that will be coupled with what's actually happening in reality in the system. One more important point also, simulations might not account for all the interactions between system components, while digital twins bring all of these interactions naturally. So the takeaway from this slide is simulations can benefit from digital twins data and components interactions to improve the modeling and then test like more what if scenarios. Now, looking at the Gartner data, it was accounted that there is 13% of digital twins that are already implemented, and then there are 62% of digital twins are in the process of being implemented. I posted a poll in the conference here, and I got really interesting responses. And then one of them is, we still don't have the alignment of expectations of different teams of like who will be creating the digital twin, who will be benefiting from that, and who will own the data. So maybe it's worth it to talk about why do we need a digital twin? The benefits of digital twins cannot be limited to, can be like listed in the following, but not limited to lower maintenance costs. Having the real-time insights to our systems enables us to furtherly consume this data into deeper root cause analysis and then filter the main parameters that lead to the fault, which in turn will translate to cost and production time saving. Digital twins help us to do system optimization. They give us like a bird view and a deep system view over all and then single components, and having such insight make the process of resources allocation analysis is easy and effective. Digital twins also help us to take better financial decisions and planning, because having a visual representation of a system along with financial data enables us to make more accurate data-informed decisions. And then also for service providers like our retail industry, digital twins enable the customer-facing teams to enhance the customer experience and deliver better services by using real data. So here are some examples of some verticals and then use cases to use the digital twins. So digital twins can be found in all industry verticals. In retail industry, digital twins are creating a duplicate digital copy of a real store, along with all the products and services. This will allow more accurate tracking and adaptive restocking, and it will also enable full product tracking from producer all the way down to the customer hands. And having such metric will enable the retailer to flag any bottlenecks along the way. It will also give an idea to the trip time of a specific product takes to get to the customer. And then coupling this information with the physical store layout can literally open unlimited research scenarios and enable us to get the optimum layout and arrangement that maximizes whatever target that we're after. For example, maximizing the product exposure, or maximizing the shopping time, or the customer expenditure. The manufacturing vertical is maybe like one of the large verticals that consumes or like that creates digital twins. The benefit of having digital twins in manufacturing is process optimization. Readings that come from the manufacturing line can be used to create a digital twin to analyze important parameters that relates to performance or adjustment to real environment parameters, and also can be done according to some root cause analysis or real data assisted what-if model. Digital twins in manufacturing helps in quality management, monitoring and responding to data from IoT sensors during the production is an essential for maintaining top quality and eliminating rework. The digital twin can also model every part of the production process to identify where variances occur or if better material or process can be used. They can also help with the predictive maintenance. So digital twins for individual equipment, or as was mentioned in the previous sessions, like sub-twins, and manufacturing can identify variances that indicate the need for preventive repairs or maintenance before some problem, a serious problem occur. They can also help to optimize the load levels, tool calibration, and cycle times. Cross-discipline collaboration, the ready availability of operational data from digital twins makes it easy to share across disciplines, or maybe like to couple with other digital twins, enable collaboration, improve communication, and faster decision making. Engineering, production, sales, and marketing, they also can work together using the same data to flow across all these disciplines to make more informed decisions. And finally, analyzing the customer experience. So digital twins are often used to collect data over time to deliver insights into the product performance, distribution, and user experience. This data can be used to help engineers and designers to improve the customer response to our product, especially through customization and ease of use. So moving on to one of the use cases, or like one of the success stories that we have at TIBCO with Visor. The freezer farm analytics that they use provides real-time status of the freezers, including the temperature thresholds, cleaning status, loaded and unloaded freezers. The farm level analysis also it gives the capacity and the utilization matrix percentages of freezers of each status, and will also gives an indications if any anomalies is happening in one of the units, or if anything needs attention, along with a detailed log that can be tracked by all team members. And this also has like many drill down levels. You can drill down to like more detailed view, or like you can drill up to a more generic view. The predicted capacity utilization also can be calculated up to 1 week in advance, and or like the number of released or unreleased doses and vials. Using this digital twin caused the reporting time to be reduced from 1.5 hours to 2 minutes for it to be generated, and also provided the ability for the teams to perform real-time tracking of batches, and that enabled also the batch consolidation, like enabled the freezer capacity farm to increase by 53% because of the new information that came into the system, and also limited any bottlenecks ahead of time by enabling forward planning for the freezer loading and cure activities. So this solution was done in a Spotfire, and also coupled with TIBCO data science, which is data analysis and modeling platform from TIBCO. And then they use this in their use case to perform the data analysis side and the prediction modeling. So the analysis of sensor data that comes from the freezer farm, or like the freezer dryers, they conclude up like the sensor output, multivariate events per batch or drugs, the several sources also of data were were used, and then all these several sources, they come to a virtual layer of data using TIBCO data virtualization, and then after that they are consumed by TIBCO data science product, which makes the procedure of like connecting to these different data sources is a very straightforward process. For example, we have data coming from AWS, from Snowflake, from SQL. They all will be like unified in this layer and will be accessed by TIBCO data science. And also Spotfire dashboards, they were utilized in this demo as we showed previously. This is also another example of using 3D augmented reality in digital twins for health training and then sport training, performance measurements. And this also brings another question is, I saw that in the poll, whether or not the 3D augmented reality is something we need to implement in digital twins. And I think that's a very case-specific question. Let's talk about the technology stack that we use at TIBCO to help or assist with the process of creating a digital twin. So in general, our technology stack in TIBCO is divided into three main pillars: the connect, the unify, and the predict. So the connect layer is the entry point of the data to the ecosystem, where we get all the data from all the different data sources. And then we can see that we have streaming, we have data at rest, we have data coming from the cloud, from data warehouses, and then maybe like any real-time data or transformation. Everything in this layer can be done using the connect product. As an example of this product is Spotfire, which is an end-to-end platform to ingest, model, and visualize the data. And also TIBCO streaming or to stream-based, it also can be used at this layer to perform any real-time analysis or like on-the-fly data transformation. The second layer is the unify, which is basically governing all this data and then controlling the access. Here we will perform any data quality steps, cleansing, and most importantly, who can access what. The unified virtual data access can also be set up here, where you can define a front end and then you connect to all these sources without worrying about configuring these sources or like these connectors again every time you need to access them. As an example of these, the TIBCO products used in this layer are the EPX and TIBCO data virtualization. And finally, the predict layer is where you perform your prediction and your data science tasks. You create your ML models, you perform any model ops and packaging and serving to the model, or like you monitor any model drifting using whether like a big data processing engines or the available engines in your premises. And then as an example of TIBCO products here is Spotfire and TIBCO data science and model ops. Now, coming to our use cases, we will use TIBCO Spotfire to manage the front end where the user will interact. And then TIBCO data science to perform any heavy number crunching, data modeling, and then TIBCO data virtualization to provide unified access layer to different data sources, and cloud streaming to stream any live data from the well path. All these products are orchestrated together to create a digital twin of the well completion process. Along with our partner Revit, the completion stage is very like we will perform that coupling from the for the data from the field ending to the user. So the completion stage is very critical part of the well life cycle, since there are like multiple components and system and data sources are incorporated. This digital twin demo is is an example of a process and equipment digital twin, where we monitor different processes, for example, the fracturing activity, pressure trends, any anomalies, the equipments, the pump statuses and other related parameters, the assets during this process, any fuel, for example, any fuel consumption, any propellant consumption, and any other consumables, like, for example, the friction reducer. So here's a brief description for our vision for the completion process as an example of a process digital twin. This is the system that we are envisioning, which is the reservoir and the well bore, and then duplicating this process. And then we also have like a couple of equipments here, the hydrofracturing pumps, and then coupling this into an accessible digital twin will help us a lot to enhance the decision and to reduce the cost and act proactively to any anomalies. And also this real data, this real live data scene can be also of great help furtherly to model this data and simulate a couple of what-if scenarios. So the parameters that we can monitor during this process are not limited to this list, but these are some of the critical parameters that we can monitor. Some of these parameters also can be fed raw into the application, and then some of them they can be calculated or like inferred from other parameters. Let's talk about this demo in detail by navigating the panes one by one. So here's the landing page of the demo in Spotfire. The sequence that you see here was created in collaboration with field engineers to be like a representation of daily tasks and the most important factors to the team want to see. The data sources come to this application are live streams from the field, and data at rest to describe the well pore properties, and then TIBCO data virtualization layer also allows the user input. So let's start by looking at these panes one by one. The overview pane provides a quick glance at the system in general, and you can see how many wells are being completed currently, and then also provides a comparison view among all the wells and the stages. We can also have an idea about the fuel consumption breakdown here, and to furtherly calculate the carbon footprint of a specific job. The visualization also provides a quick way to compare the performance with respect to predefined daily goals. And then this page also can be automated to be sent in a form of a PDF report for the management, for example. The treatment plot, this is one of the most important visualizations in the completion process, which shows each stage completion in terms of pressure, propellant usage, and also flow rates and time series sequence. It also shows the current values of these parameters, which well is being completed currently, and we also have implemented an activity detection rules that predict the current activity based on these parameters as an example of furtherly using the data to create more insights. The stream here is fed into the application using TIBCO data streaming. Moving on, this is the wireline activity and pump down visualization, which gives you a historical and real-time view to the process of running the wireline measurement tools. The visual also can connect to different data sources from different vendors. This is the coil tubing visualization, and also a visualization for all the activities that happen in the wellbore, time-stamped and also referenced by depth, and also you can take a look at them with reference to the time. And then in here, you have an idea about your material consumption, and then time usage analysis, where it gives you an idea, a comparative idea among all the wells that you drilled, how much material you used, and for example, the propellant you used, the friction reducer materials that you used, to like have an idea where did you have an anomaly, or like where did you like overuse some of the materials. This is where all the crews interact. So in here, there is a geographic representation where all the crews are right now, and then they also can share some notes, some updates about what is happening, and then all this can be like stored into a database. Finally, this is an example of using the digital twin data to furtherly do some predictions using data science. So what we did here, we use unsupervised learning and clustering analysis with the help of TIBCO data science to perform some formation pressure prediction and an instantaneous shut-in prediction. And this is an example of furtherly using the digital twin data to perform some prediction. In here, this is an example of coupling another digital twin, which is, we call them the accelerators. This is an intelligent monitoring for the equipment. And in here, we basically use this accelerator to monitor the health status of the fraction pumps in terms of, let's say, the pressure, the flow, or like any anomalies. So I will also touch on one of the success stories that we have with Formula One team. So Formula One racing is probably the most competitive, technology-intensive sport in the world. With this use case, there are 300 sensors, 65 channels of data, and 50K data of points per second being brought to the digital twins. And there are like hundreds of parameters. A large number of setups are tested pre-race, like suspension, car balance, tires, and track evolutions. There are like also test scenarios. So there is a pre-race setup where they run and then test different parameters, and then there is like the final setup that they use before the real race. This is an example of using digital twin to predict the lap time. This is one of the this is in one of the TIBCO analytics forum where we use simulation coupled with digital twin of the car to predict the lap time. And this is like an example of using digital twin data based on the current parameters to predict also the likelihood of a crash, for example. So to achieve the continuous success and keep competitors at bay, teams must acceptably wrangle the volume and variety and velocity of their data and turn into a competitive advantage that fuels innovation. Data analytics supports the game plan and the minute-by-minute decisions made by the garage drivers and all the team stakeholders. With every circuit, and relating competitors and changing weathers and track conditions, data analytics and decision making are crucial. See, the F1 team and TIBCO collaboration is great. The smallest edges in car design, these are all affecting factors on the performance. And also the driver preparation and then race day strategies account for all these gains of seconds, which accumulate into a total gain. How fast you can transfer and analyze the data is one of the crucial factors here. So coupling these with further analyses and deep dive modeling can be also of great help to optimize the system and achieve more gains. So imagine how hard this task will be without having a virtual representation of this complex system. So this concludes my presentation for today. I hope you will find it useful. Thank you so much for having us. I will be happy to answer any questions.
Thank you, Athir, for sharing such an insightful information on digital twin technology. We have a question from Ekanao that can this be used to detect theft and vandalization of crude and oil gas pipeline, and how?
Can you repeat the question? I'm not sure I heard it.
Can this be used to detect theft and vandalization of crude oil and gas pipelines? So can this be used to detect theft and vandalization of crude oil and gas pipelines? And if yes, then how?
Yeah, so we have a use case where we for the midstream analysis is where we visualize the whole network of pipelines in real time, coupling that also with OSIPI data. And then you can you can reach out to me, and then I can give him more details about the use case that we have.
Thank you, Athir, for answering the question. Akana, you can reach out to him directly if you need to, if you need more information on this. We have another question from Randall is on projects in past in 2017. I have seen spot file linked to P6 and systems completion database for dashboard reporting, but it required a lot of backend coding to get to it to provide unified visualization. Has the UI since been enhanced to allow more low code, no code visualization?
Yes, if you're talking about the data science part of it, yeah, the data science platform is almost geared toward not having the users to do a lot of coding, and also the TIBCO data virtualization. It doesn't require you to perform a lot of coding, and that's the whole goal out of it. It's to let's say make the entry barrier to these products is as low as possible. So of all the, let's say, the data science citizens, they can use these products. So the short answer, yes, it should be a very low no code very low code environment.
Okay, thank you for answering the question. And so yes, it is possible to have low code, no code visualization. We have another question from Kevin Shee. In the TIBCO model of ops, what is the difference between model management and model governance?
So I would put it this way: the model management is monitoring the model, and especially like the model drift. While the model governance is basically creating some rule-based access to like who can update or like tune the model. So one of them is monitoring the model itself, and the other one is like monitoring or like ruling who can access and update this model.
Thank you, Athir, for answering the question. We'll wait for a few more minutes. So if the audience have any questions, they can post it on the question and answer section. I would request all the attendees to post a question in question and answer section. I believe there are no more questions from the audience. Thank you, Athir, for giving such a wonderful presentation. I would suggest all the attendees to connect with you directly to have more information on the given presentation. I thank everyone for attending this session, and you can also visit TIBCO on the exhibitor booth as they are a gold sponsor for this event. Thank you, everyone.
Thank you for having us, Alex.
Okay. We'll have a break for an hour. We'll get back on the session at 12:30. Thank you, everyone.
Thanks.